Hello everyone, welcome to my channel Arthashastra Classes. In this video we are going to solve a previous year question. This question was asked in June 2019 term and examination. As you can see on your screen, it's a 20 marker question of section A. So let's solve this question. I hope you are ready with your notebook and pen. So let's start solving this question. Okay, in question we are given a consider a COBB-DOUGLAS utility function u, a function of xy, and the function which is given to us is x alpha times y raised to the power 1 minus alpha, and remaining information is related to budget constraint. So our first step is to write down the given information in our own language. So I have written given information u, a function of x and y, where x and y are two goods that a consumer consumes, equals to x raised to the power alpha times y raised to the power 1 minus alpha, and this is a standard COBB-DOUGLAS utility function. Another information which we are given is related to the budget constraint. It is given as px is the price of good x, py the price of good y, and m is the money income of consumer. Now from this information we write down our budget constraint. It is px times x, that is the expenditure that a consumer does on consumption of good x, and it is the consumption of good y in money terms, less than or equal to m, his total income. So this is what we have derived from question. Now let's see what we are asked to find out. So in first part we are asked to find Marshallian demand functions for both the goods. Okay, the Marshallian demand functions are also known as ordinary demand functions or WALRASIAN demand functions or uncompensated demand functions. You might encounter any of the term in your examination, so focus on this. It's important that whenever any of the term comes, we have to do the following solution. Okay, whenever we are asked to find Marshallian demand functions, we need to set up the utility maximization problem. For this, what we are going to do is we are going to write this stepwise. So I am writing step 1 as set up the utility maximization problem, UMP. Okay, let's first understand what do we mean by utility maximization problem. It is the problem of a consumer who aims at achieving the maximum utility subject to his budget constraint. So we can formulate this UMP in numerical terms as UMP. Our objective is what? To maximize the consumer's utility. So objective is maximize utility, that is a function of x and y, subject to what? The consumer's budget constraint, which is px times x plus py times y less than or equal to m. Or in a specific case, that is maximum, what is a utility function? It is x alpha times y 1 minus alpha, subject to, ST stands for subject to budget constraint px times x plus py times y less than or equal to m, x greater than 0 and y greater than 0. Now these are two additional constraints which mean that the consumption of x and y are non-zero and non-negative, and this entire problem, this entire setup is our UMP. You have to mention that this is our entire setup UMP. Okay, now we try to solve it. So we write down our step 2. It's important in exam to present your answer nicely, so you please mention the steps. It is set up the Lagrangian expression for constrained UMP. Okay, whenever we encounter any maximization problem or a minimization problem, we have to set up the Lagrangian function. So what is our objective to set up Lagrangian function? Our objective is to maximize, because we are encountering the maximization problem of utility. So to maximize the Lagrangian expression by optimally choosing now what we have to optimally choose: the quantity that consumer is going to consume, that is what quantity of good x and what quantity of good y a consumer should consume such that his utility maximizes given the prices of two goods and his money income. So he is optimally choosing the two goods x, y and lambda, where लैम्डा क्या है? एक ये अननोन लैग्रैंज मल्टीप्लायर है एंड ये ग्रेटर देन 0 है. तो लैग्रैंज क्या हुआ हमारा? मैक्स लैम्डा सच दैट वी आर एमिंग टू achieve maximum of utility. So utility a function of xy plus our budget constraint. So we use this multiplier as here, and we had budget constraint as m, we take it in minus px x minus py y. If you don't know how to solve a maximization problem and a minimization problem, I will make a separate video on that so that you can understand. So this is the general form of any Lagrangian function of UMP problem. So you have to write this. Now we write our specific Lagrangian according to a given utility function. So it's max x raised to the power alpha times y raised to the power 1 minus alpha plus lambda, and since we are not given the values of budget constraint, we are going to write as it is. So this is our Lagrangian function. Okay, this is our required Lagrangian function. Our next step is to set up the first order conditions. So our step 3rd is to find out first order conditions. Please mention these steps when solving any question in your paper to get full marks in numericals. We also call it as FOC. Okay, so for finding first order conditions, what we will do, we will differentiate this Lagrangian function with respect to the variables. So what variables are there? X, y, and this are Lagrange multiplier lambda. So start differentiating. First we write down, presentation is important in your examinations, so we write down to determine FOC, we differentiate the Lagrangian expression with respect to x, y, and lambda. So del L by del x. Okay, now we are differentiating this function with respect to x. Okay, so we can write it del by del x whole of x alpha times y raised to the power 1 minus alpha plus lambda m minus px times x minus py times y. Okay, so let's start differentiating. See, x raised to the power alpha, and whenever differentiate a function x raised to the power m, the differentiation is mx raised to the power m minus 1. So following the same rule, we differentiated alpha times x, alpha minus 1. Y will remain as it is because we are partially derivating 1 minus alpha, plus since this is in multiplication, lambda will remain as it is. Now m is a constant. While differentiating it with respect to x, it will become 0, minus x derivative will be 1, and this is a constant in multiplication, so it will remain like this. It does not involve x, so its derivative is 0. So what we get, del L by del x as alpha x raised to the power alpha minus 1 times y 1 minus alpha plus lambda minus px, so it becomes minus lambda px. Okay, similarly we can derivate it with respect to y. What we will get, partial derivative of the whole Lagrangian function with respect to y. So del y whole of x alpha times y 1 minus alpha plus lambda m minus px times x minus py times y. So what we will get, x alpha being a constant, it will remain as it is, so 1 minus alpha will be taken outside times y 1 minus alpha minus 1, okay, times x alpha. Again the same differentiation rules, we will get plus lambda, differentiation of m with respect to y will be 0, minus differentiation of px times x with respect to y again will be 0, minus differentiation of py times y. So y ka differentiation with respect to y is 1, we get minus py. We write down it again, so it's del L by del y as 1 minus alpha. Now this will cancel out 1. Okay, so we cancel it out, 1 times 1 cancel out हो गया. अब क्या बचा, y minus alpha times x alpha minus lambda py. Okay, next we will differentiate it with respect to lambda. So differentiating our Lagrangian function, del L by del lambda, what we will get? The entire utility function with respect to lambda will become 0. That is del by del lambda. We have x raised to the power alpha times y 1 minus alpha plus lambda m minus px times x minus py times y. So when we will differentiate it with respect to lambda, what will become? This entire term does not contain lambda, so its differentiation with respect to lambda will be 0. So we write down 0 plus, now this is in multiplication, so will be treated as a constant. We will write it as it is, minus py times y, and differentiation of lambda with respect to lambda will be 1. So what we get? We get del L by del lambda equals to m minus px times x minus py times y. Now what we will do, we have find the derivative with respect to all the three variables. Our next step is to set the derivatives, set the first order derivatives equal to 0. So we will set our first order derivatives equal to 0. So we are setting del L by del x equals to 0. So what we will get? We will get alpha x alpha minus 1 times y 1 minus alpha minus lambda px equals to 0. Further we will get, by taking this term to RHS, we will get lambda x lambda minus 1 times y 1 minus lambda equals to y 1 minus alpha equals to lambda px. We term it as 2. Setting del L by del y equals to 0. We get 1 minus alpha y 1 minus alpha minus 1 times x raised to the power alpha minus lambda py equals to 0. So we will have 1 minus alpha y minus alpha times x alpha equals to lambda py. We again took this term to the RHS. Del L by del lambda equals to 0 will give us m minus px times x minus py times y equals to 0. Taking these two negative terms to the RHS, we will get m px times x plus py times y. We term it as equation 3 and this as equation 4. You can note that this is our equation of budget line. Okay. Now we aim to solve for either of the good, that is either we can solve for x or we can solve for y. So we will solve it. We can divide equation 2 by equation 3 to simplify. So what we are going, the del L by del x over del L by del y. We will put this expressions here, alpha times x raised to the power alpha minus 1 times y raised to the power 1 minus alpha over 1 minus alpha y raised to the power minus alpha times x raised to the power alpha equals to lambda px and lambda py. Now we will cancel out the terms, so lambda cancels out, and now what we will do is we will take the x terms together. So we will take x raised to the power alpha. No, we will take numerator to the denominator and its denominator to numerator. So what we will have is alpha times y, 1 minus alpha. We take it to the numerator. So what we will have, 1 alpha. Here 1 minus alpha, we have x alpha. We will take this term to the denominator. So it will become x minus lambda plus 1 equals to px over py. Okay. Now bases are same, so we can add on the powers. As you must know, if a raised to the power m times a raised to the power n, we have a m plus n. So using this exponential rule, we will add the powers. So we have alpha times y, 1 minus alpha plus alpha over 1 minus alpha times x raised to the power alpha minus alpha plus 1 equals to px over py. On adding, we have alpha cancels out, here also cancels out. So alpha y over 1 minus alpha times x, this is px over py. Now this condition is of prime importance. Why? This is the equilibrium condition of consumer theory. What it is? This is MRS and this is the price ratio. In turn, what is this? This is slope of IC and this slope of budget line. So you need not to mention this in numerical. It's for your understanding. I have explained it. Okay, so we will term it as equation 5, and now we will move further. Now from equation 5 we have alpha over 1 minus alpha times y over x equals to price of x over price of y. We can solve it for any of the good. So I'm solving it for y. So solving for good y, what I get, I will rearrange the terms, or on rearranging, what we get y equals to px times py. This entire term will come here with the reciprocal, so 1 minus alpha over alpha, and this will come like this, or y is 1 minus alpha over alpha px over py times x. This is our equation number 6. Okay, now we are going to substitute equation 6 in equation 4 to solve exceptionally for good x. So equation 4 we have m as px times x plus py times y. Okay, we substitute for y. M equals to px times x plus py. This whole expression will come here. It will become 1 minus alpha over alpha px over py times x. See, we get xx. This was our objective. We cancel out py, and what we are left with? We are left with m px times x plus 1 minus alpha over alpha px x. Now you can see these two terms are same, so we can take them out as a common term. So it becomes px times x into 1 plus 1 minus lambda over lambda. Solving further, we will get px times x into, we will take LCM, we get alpha plus 1 minus alpha. So alpha cancels out. We are left with px times x into alpha, right? Okay, on rearranging, we will get x equals to alpha m over px. Now this is our Marshallian demand function. Okay, now to find out the Marshallian demand function for good y, we will substitute this function in equation number 6. So let's start substituting. Okay, so we have y as 1 minus alpha over alpha px over py. We substitute for x star to get y star. So y star will become 1 minus alpha over alpha px over py times alpha over m times px. Now we will cancel out the terms. Alpha will cancel out. We are left with y star equals to 1 minus alpha times m over py. This is our This was our Marshallian demand function for good x. This is our Marshallian demand function for good y. Now this is what we solved it. Let's focus now on the representation of this. How we represent that? So representation, we represent ordinary demand functions or Marshallian demand functions as x star, where x is a function of px times a function of py or a function of m. So let's see. So this is our demand function and it's a function of m and px. This is our demand function, it's a function of m and py. So we get it as alpha m over px and our Marshallian demand function y star is a function of price of the two goods and the income of the consumer equals to 1 minus alpha over m p y. So this is for good x and this is for good y. And yes, this is our answer. So we have solved part 1. I would like to tell you that whenever you solve a COBB-DOUGLAS utility function, you will always find this ordinary demand functions in this form. Here, since you noted that the power of x was alpha, so whatever is the exponential of good 1 will come here, and whatever the exponential of good 2, it will come here. So you can cross check this. Indirect utility function. So what is indirect utility function? Indirect utility function is defined as the indirect utility function is defined as the maximum utility that a consumer can attain given his money income and good prices. See, it's a numerical question. You might write this definition or you can skip it as well, but the standard notation you have to write it in numerical. So what's the standard notation of utility function? Indirect utility function is V. We denote indirect utility function by the alphabet V, and U stands for utility function, V stands for indirect utility function. So it's a function of P1, P2 and M, that is the prices of two goods and the money income of the consumer, whereas the utility function is the function of two goods, that is the quantity of two goods X and Y. So as you must have observed that we have found out the Marshallian demand functions, which are also a function of prices of two goods and the money income. So it's nothing but the utility function as a function of the Marshallian demand functions for two goods. So X star P1 P2 M comma Y star P1 P2 M. What is this? This is Marshallian demand function for good X. And what is this? This is Marshallian demand function for good Y. Now what we have to do to find out the indirect utility function, you just have to substitute. Okay, what was a utility function? It was x raised to the power alpha times y raised to the power 1 minus alpha. you just have to substitute the ordinary demand functions or the Marshallian demand functions in this function to find out the indirect utility function. Okay, so what will u x star comma y star क्या होगा? It will be x star raised to the power alpha times y star raised to the power 1 minus alpha. What is this? We substitute for the 2. So we will get alpha m over px whole raised to the power alpha times 1 minus alpha times m divided by py whole raised to the power 1 minus alpha. So this is our indirect utility function. We present it as v px py. See, you have to change the notations. The price of good x is px, not p1. This is the general form. This is a standard notation, so take care of this. These are the small things wherever you lose your marks in papers. So it's alpha m over px alpha times 1 minus alpha m over py whole raised to the power 1 minus alpha. Now we can simplify it if we want, but if we are leaving it there, then it's no problem. So we can say it's our required indirect utility function. So moving forward to third part of this question, we are asked to find the maximum utility attained by the consumer, and we are given values. Okay, so let's first write down what we are given. We are given alpha as 1 by 2, price of x as rupees 2, and price of y as rupees 8. Given m as rupees 4,000. Okay, now remember that we have found out the Marshallian demand functions by maximizing utility. So the functions which we have derived as Marshallian demand functions are nothing but those values of x and y that provide maximum utility to the consumer. So we can directly substitute values in the indirect utility function to find the maximum utility of the consumer. So our indirect utility function was v, a function of p1, p2, m as alpha times m over px whole raised to the power alpha 1 minus alpha times m over py whole raised to the power 1 minus alpha. Now we have to simplify this, so we start simplifying it. Okay, I'm taking these powers out, so I can write it alpha raised to the power alpha times m raised to the power alpha times px raised to the power minus alpha. This whole times 1 minus alpha raised to the power 1 minus alpha times m raised to the power 1 minus alpha times py raised to the power minus of 1 minus alpha. We can do this numerical without expanding it as well. So let's take a short route. I'm going to substitute the values directly in this. So I'm given the lambda as 1 by 2, m as 4000, and px as 2. So whole raised to the power half times 1 minus alpha. If alpha is half, so 1 minus alpha will be equal to half only. So it's half again. M is 4000 and py is 8. So this again is the square root. You just leave out this. So we have v, p1, p2, m, or you can say max of u is, we'll solve it. So let's start solving it. We cancel out by 1000, and here we can cancel out 2000. Dividing on this will give us 250. So we have under root 1000 times under root 250, that will be equal to 250. So it's the square root of what? So 50 का स्क्वायर रूट नहीं, 500 का स्क्वायर रूट होगा अंडर रूट 2,50,000. So our answer is 500. So maximum utility which a consumer derives is 500 utils. This is the maximum utility a consumer derives given the prices of two goods and his money income. Okay, in next part we are asked to find out the Roy's identity is the last part of this question. We have already solved the 3 parts, and since this video has exceeded 40 minutes duration, we will solve it in another video. I will make another video solving part 4 of this question, that is Roy's identity. If you find any mistake in solution, then please enlighten me in the comment section below. If you find this video helpful, please like it, share it with your friends, and subscribe to my channel for more such videos. Your little support is my inspiration, so please support me by liking, sharing and subscribing to this channel. Thanks a lot for watching this video. See you in the next video. Bye bye.